Hi class, this week's lab is molar mass of a volatile liquid. And this is a pretty easy lab. I like this lab, especially when we do it in person. The downside is the lab smells like a nail salon, really concentrated from everybody's unknown compounds, but it's a really easy lab. So this is not difficult to I don't believe most of you should have problems with this lab. Molar mass of volatile liquid. Let's cover molar mass. By now, hopefully everybody should understand how to determine a molar mass of a compound. It is always grams over 1 mole. The one is not there, it's defaulted. It's something that you guys should know. So when you hear molar mass, that means the compound should have units of grams over moles. For this experiment, the unknown must be a liquid with a low vapor pressure at room temperature, boil below 100, and obey the gas law. There are certain conditions that real gases do not obey the gas law. I'm not going to go into them here, but this one for this lab, if you had been doing this in person, it would follow the ideal gas law. You do not know what your unknown is, you're not going to know what it is, and you don't need to know what it is, really, because the math itself is going, if you do this correctly, you should have no problem. You're going to determine the molar weight of a volatile liquid using the method of Dumas. This method is no longer used, but back in the day, for low vapor pressure liquids, they used to determine molecular weights this way. I'm going to do a quick overview of what you're going to do in the lab, but you will need to read thoroughly what Entis has posted up. So a liquid is placed in a container with a very small hole. So in person, Citrus has made these certain glass bulbs. It's called a round bottom for this lab specifically. And so the prep is really easy. But if you look at the pictures of this, it's usually some kind of flask with foil on top and a pinhole of a hole pinched into the foil. So a liquid is placed in a container with a very small hole. The liquid is then heated in a constant temperature bath, such as boiling water, until all the liquid vaporizes. This is when the whole lab smells like a nail salon. Excess vapor escapes via the hole in the container. The remainder is sufficient to occupy entirely the container's volume at the temperature of the bath and at the pressure of the atmosphere. So basically, you're going to boil this, and enough of it, the excess is going to leave through the pinhole, but you're still going to have enough of the vapor to be able to determine the slab, to complete the slab. The liquid is vaporized into a fixed volume vessel at a measured temperature and barometric pressure. So basically, you are going to determine through the experimental conditions the pressure, the volume, you already know what gas constant is, and the temperature of the boiling water. So once you determine all of those, you're going to plug it in and determine the vapor of your unknown. So here I broke down, if you look at the PDF that Entis gave you, this is what these equations match to, and the colors coordinate to where they place in the equation. So this is blue. This is the first step once you determine the conditions of the experiment. You're going to determine the moles of vapor. Once you determine the moles of vapor, you need to determine the mass of vapor, and that is simply the flask with the vapor after boiling minus a clean flask, and that's going to give you the mass of vapor. Then one more step, very easy. Remember what molar mass is? It is grams over mole. You're just going to plug these in and determine the mass of your compound. Now keep in mind, these slides are directly from my lab. I don't know if Entis has changed anything on Canvas. So this, if he has not, it should be very straightforward. You shouldn't have problems with it. Just if you do not get your final answer in grams over mole, you did something wrong and you need to go back and see. There's a certain portion that discusses van der Waals. Ignore it. We're not using it. This is what I'm giving you is what you need if Entis has kept it exactly like it is in the lab. If you have problems with this, if you pull up the PDF that Entis gave, there's a pre-lab that would normally be done by you before the lab started, and this is it. I did it to help students understand. So if you needed to look at this, you could break down and see what I did step by step, matching and tried to match it as close to the table, the chart as possible. Part B. So part B is not something that we do in lab. I don't have anything to do with this. But since Entis has asked me not to get involved in Canvas, I'm not. These are slides from last semester, spring. So technically, I'm not cheating. I put something together for my students, and if he has not changed it, then this should be able to get you through part B as well. So combustion analysis of a sample, again, you don't know what it is, 28.4 grams of an organic compound. Anything organic has carbon and hydrogen and sometimes oxygen as well. Produced 54.3 grams of CO2 and 15.6 grams of water. We need to find the empirical formula of the unknown compound. So what I normally do is I put up a generic balanced equation. This is not to, we're not using this, but I always write out equations, and I always write out the masses underneath it so I can see visually what I'm doing. I'm a visual learner. I need to be able to see everything. So the first thing I'm going to do is I'm going to tackle the CO2. We have it produced on this side. So I need to get to carbon. It's simple stoichiometry. You guys should be very good at doing this by now. When I saved it, it looks like it moved some things over. So you need two things. You need the mole, and you also need the grams, because you're going to have to subtract from the unknown to get the oxygen. So make sure you do both, and it's just one more step when you do it anyways. So I did that. I broke through stoichiometry. I was able to determine my mole of carbon and then my mass of carbon. And I'm going to do the same for hydrogen. Why are we not doing oxygen? Because oxygen is in both compounds. So we don't know exactly how much contributes to CO2 and how much contributes to water. So it's easier to focus on carbon by itself and hydrogen by itself. And then process through subtraction, determine what the mass of oxygen is. That's what we do. I determine my moles of hydrogen, and then I determine my mass of hydrogen. As you can see, I subtract and I determine what my moles, my grams of oxygen are. Then the third step is exactly like the other ones. I determine my moles of oxygen. So even if you're a little rusty on this, you guys should have an idea of how to do this. And once, hopefully this slide will help you be able to. But we're not done, because now we have our moles, but we need to get to empirical formula. So I brought this over again. You can see I now brought over my information with my moles. You divide by the smallest amount, and that is oxygen for mine. This is not going to match what Entis has, I believe, online. And then you divide again, and these are fractions, so you need to get whole numbers. You guys should all know how to do that. Multiply every value by the same number. Hopefully it works out to get you whole numbers, and once you get the whole numbers, you plug it in. And here is my empirical formula. So it may seem overwhelming at first. Just take your time, do it by steps. Believe me, you guys already have the knowledge to do this stuff if you're in this course, and you just got to learn how to break it down. So it's not too bad. And that's it. So if you have questions about this lab, you know how to always contact me, or you can ask each other. This lab will be posted at 11:30, and then your write-up for it will be due next Thursday. Now the write-up, I didn't make it anything special. Entis had already put up the sample sentence that you'll have to put and post-lab questions. And that's it. I'm not going to ask for too much from this lab. The answers, give me your best effort, explain it as well as you can. I don't expect, I expect the effort. I expect an effort. Doesn't always have to be right, but I expect an effort on thought process. Clear sentences, not one-worded, complete sentences that make sense. If I don't get that, you will lose points on that. Okay, and then it brings me to one more slide. I apologize. I am really late on grading. This semester, not running my own course has been confusing for me, and I don't know how to use Canvas. So I am learning how to use Canvas, and then it turns out there's things I have to grade that I wasn't a part of. So I am right now learning that stuff, and then I'm going to go in and grade. How does this affect you? Well, it actually works in your favor because if I didn't grade it in an acceptable time, I'm actually going to be pretty lenient with most of it. Only the conditions of if I catch that something is too similar to somebody else's and I consider it cheating, I will probably deduct it down very much. And if I see a consistent pattern, I will bring it to Entis's attention, and you'll probably fail the course if I can prove it, because in this course, I know things are difficult, especially being online. but don't cheat. That's the one I try to work with stuff, but that's the one thing I won't do. So as long as I don't see a consistent pattern of certain things, and you would know, I will contact you personally. We will have a meeting before we have a meeting with other administration involved. So just keep in mind, and don't get panicky. I'm not talking, there's, mostly I believe the students are doing everything on their own and struggling through it. So don't think I'm talking to just directly one person. I've just started. I don't know. But overall, this may help 99% of you because of the fact that I'm not going to grade it to the usual standards that I normally would because I am so far behind. Um, not understanding my role for this course, not being able to access certain things. And I'm not blaming MTIS. MTIS is doing the best he can. He's doing 3 courses of this and he's trying to single-handedly keep it going. So I things get lost in communication and lost in the crowd. But I'm trying to recover from that now, and I would be very generous with my grading. But here's the catch. Once I catch up, I'm going to expect the effort that I expect from students that are in Chem 111. So then I'm going to grade it exactly with what I expect. So it's not a free ride through the whole thing. Um, and that's it. So just be aware. I apologize. I'm working on it, and to make it up, I'm not going to be as stringent as I have been on my grading right now. But once I catch up, and it's probably going to be with this lab that I'm presenting right now, I'm going to grade it. But again, even with what you're training in, isn't that bad. Okay, if you have any questions, you know how to contact me. Thank you.